Okay, now I'm also live. Yeah, welcome to our session about Project Strawberry. Max and I are both working at Neo4j in the graph data science team as software engineers, and we want to show you what we worked on in the last months on a new way on how you can use the graph data science plugin. But before we start talking about actual Project Strawberry, let's give you a short recap of what we actually mean with graph data science. So I brought here a couple of use cases which we associate with graph data science. So for one, you can think of, you have a social network and want to find out what are central persons in the network. For instance, who should you influence to sell more strawberries in general? Or you have another social network where you have people with social security numbers and emails, and you see there's a person with more than one social security number, which is a bit shady, and you're thinking there could be a whole community around it. So with graph data science, you can find whole communities. And also at last, there is an example of where you want to find out whom someone would like to follow, for instance. So a person likes football and also is fan of a specific club, and you can predict the link between them and a football player, so called link prediction. So these are like three typical use cases of graph data science, and now let's give the context to Neo4j. With Neo4j graph data science, we have an offering where you have a couple of high-performance graph algorithms. So, like for instance, PageRank for centrality, WCC for community detection, or like Node2Vex for embeddings. What makes us a bit special is that we are focused on running at scale, so talking about 100s of billions of nodes, and also offering them highly parallelized, so trying to make sure all of your CPU cores are actually used and not just idling around. And when we look at the typical workflow of GDS, then it starts with that you have your database and project a subgraph into in our GDS graph catalog, which is in memory, so not persisted anymore. On the subgraph, you run a couple of algorithms, like for instance, PageRank to compute centrality scores. And you can also run a couple of algorithms. So for instance, first component detection, then run like something on each component. And once you're done with your pipeline, you can consume the result. And that's either you write it back to the database, so persisting it, or you can also stream it to a client and maybe inspect the results first before you want to write back. And that's what we envision the typical use case with GDS to look like. And let's look next into how the existing setup is. So GDS is a library, a jar, which lives in the plugin directory of the database. And it's automatically loaded at database startup if you installed it. And you connect to it using a client, same as you use for the database. Can be in the language of your choice, like Go or Python, and then you execute Cypher queries. And so GDS is exposed as Cypher procedures. And here I brought an example for PageRank. So if you want to run PageRank in write mode, you do gds.pagerank.write. But there are a couple of challenges with the current approach. So for one, it can be resource contention, and the one dimension of having just lots of users that want to call GDS algorithms at the same time. So they are competing with each other about resources. And as it's all running on the same machine, even the same JVM, there is only a limited amount of resource. And so because one has already this huge embedding algorithm running, another one might not have enough memory and or CPU available to run their shortest path, for instance. And in another dimension, it's also, we are competing with the transactional workload that is also on the database. And as we're sitting on the same JVM, we are sharing the same heap. So in the worst case, we might be influencing the transaction workload that can't run properly, or the other way around, that algorithms don't have enough resources because there's so much transaction workload. And another challenge that people are seeing is the usage pattern. So often a database instance is running 24/7, and with GDS you have a bit more resources, so you have a bit larger machine for it. But actually the amount of time you need these resources, or a lot of these resources, is only for a very short amount. So analytical workloads like GDS are more on a batch level or so, and not 24/7. And with these challenges in mind, we started Project Strawberry, where we had the following goals. So one, we want GDS to get ephemeral. So ideally, they only live as long as necessary and are completely shut down afterwards, such as it could be a separate machine. It should be also scalable, so it should be possible for multiple users to run their GDS workloads at the same time. And also it should be quite easy to realize my current machine is too small for my workload, I want to beef that up a bit. And at last, we also want to make it easy to get the latest data in your GDS projections. So for instance, in the Aura world right now, what you have to do is you sync your data from your AuraDB instance to AuraDS, which is more of a manual process. So that was also a goal that we wanted to simplify. Let's look into how we have it currently deployed in Aura. So the idea is that there's a GDS Python client sitting on top of it, and you can create GDS sessions. These are standalone in that sense, but each GDS session is associated with one AuraDB. And so after you created the session, you can then project your data from the AuraDB to the GDS session and also write it back. The main difference here is that the AuraDB and the GDS session are different boxes and not just one. And now with all these theoretical details, let's get straight into a demo. And I'm handing over to Max.
All right. I will switch over to my Python notebook here, where I want to give you a short sneak peek of what we've currently designed under Project Strawberry and what we are currently testing with certain customers, but more about that later in the talk. We'll do a short hands-on, so you see how we imagine sessions to feel once they hopefully end up with you as customers. And yeah, let's dive in. So we have our notebook here. I'll first do some imports. It's all in Python. Florentin already mentioned that the GDS sessions are currently only available through our GDS Python client. But it should, for those of you who are already familiar with the Python client, it should feel very familiar, actually. So there's only a couple of lines that you have to do in addition to the workflow you might be used to. And then you basically get access to sessions and all the benefits they hopefully bring you. So since we are now interacting with Aura, Florentin mentioned all GDS sessions, they run in Aura. So we need you to authenticate with Aura. For that, we need your Aura client ID and the client secret. Those you can obtain through the Aura console. You also, in my case, need to specify the Aura tenant ID, but that might or might not be the case for you. And then we can create this GDS sessions object. This is basically the main entry point into sessions. And that object allows you to create, destroy, and inspect existing sessions. It, again, needs those Aura credentials and my tenant ID. That doesn't take any time. And now we can dive right in and create our first session. Currently, sessions are always linked to a Neo4j database. So you can have many sessions for a given Neo4j database, and a session is always linked to a single Neo4j database. In this case, we'll use an AuraDB that I've already created. It contains a LDBC scale factor 1 database. That's the LDBC social networks benchmarks database. And we'll use that to run our demo. So we have here our database address and credentials, and we use them to then call sessions.get or create. We'll now create a new session. A session has a name that's there, so you can come back later and resume your session or connect to an existing session, I should say. So let's say, for instance, you start a workload with a session and then your workday ends. So you just shut down your computer, close your laptop, and then the connection of the Python client to the session gets lost. But using this name, you can later reconnect to your session. We specify the size of the session. That's currently done similarly to AuraDB or AuraDS, where you define the session via its memory, main memory. And we also offer a suggestion tool, such as you're used to when you create a database through the Aura console. Then we need our database connection details, and we also can specify a time to live. We imagine sessions, as we already mentioned, to only run for as long as they are needed. So you should be able to start a session, do your work, and then power down the session. And that would be only for that time frame you would be charged any money for the session usage. But it might be that you forget to shut down your session or your Python client crashes, and that's where the time to live comes into place. So the session will be automatically deleted after the specified time to live, and if there was no activity. So let's say you stop doing anything, and then in that case, after 5 hours, the session would be gone, and you would be no longer charged any money. So now our session has been created. This time it took 28 seconds. That's a good average. We've been creating it on GCP. It takes various amounts of times depending on the size of your session and the time of day and the cloud provider you're using, and we are still trying to optimize that startup time. But we are aiming for some time between half a minute and maybe a minute. Just to make sure that we actually have created our session, we can now call session.list, which will list us all our available sessions. You shall see 2 here now. One I created as a backup if anything goes wrong, and then the one I just created, Notes24 demo. It has a session ID. We can see the size and some other information like the time left to live for that session. What you'll also notice is an expiry date. Sessions have an explicit non-changeable expiry date, so they will be gone, I think, after 1 month. That's a hard stop, and after a month, a session will be terminated. But we imagined, again, those sessions to be used only for a couple of minutes or hours, and not for a whole month or longer. Now that we've got our session, we have access to our GDS object. That's, for those of you who are already familiar with the GDS Python client, that's the main interaction point for Python and GDS. And from here on, it basically works pretty much the same as you're used to. First of all, we need to project a graph. And now the question is, how do we actually get the data from the Neo4j database, the AuraDB in this case, onto the session? They're different machines, so they don't share any direct memory connection or is common process. So how do we actually get data from the database to the session? And here we've invented GDS Graph Project Remote, or remote projections as we call them. They work pretty similar as the newer Cypher projections that you might already know. And they work in such a way that you write a Cypher query where you first match all your data, you get access to the data within the Cypher execution environment, and then you call this aggregation function. And then basically what we are projecting is triplets of source, target, and then the implicit relationship between them. So here we basically just match the entire graph. We have our source node, our relationship, our target, and then we define a nonsensical property here. We have some labels for the source nodes, labels for the target nodes, and a relationship type for each relationship. We also define a batch size. That's just internal details about how how big the chunks are that we'll send over the network. And you'll see this time it took about 20 seconds to project 3.1 million nodes and 17 million relationships. Now we also have access to our graph object together with the GDS object. That means we can actually run an algorithm. Let's run PageRank in mutate mode. And that will mutate the result of the PageRank algorithm on each node under the PageRank property that went fast, like in, what was it, 3.1 seconds? No, that's not it. Yeah, 3.7 seconds. And we can also, since we've mutated that property, we can use it in a follow-up algorithm. He'll rerun an embedding algorithm, fast-RP, and we'll use the PageRank property as a feature, and again store the resulting embedding under the embedding property. We'll do that as well. Similarly fast. And now we can actually inspect our data. We can retrieve it. This is done via Apache Arrow. I'll only retrieve the PageRank property because I'm in Germany and have not the best internet. And that's quite a lot of data. So I'll only retrieve the PageRank property here. We should see that soon. And here we are. So we now can see we have, for each of our node IDs, we have a PageRank calculated. And we have the same number of rows as we had nodes in the graph. Imagine now that you're done with your computation. We were interested in the PageRank property and then embedding. We can now go ahead and write the data back to the database. That also works via a remote mechanism, but the interface, we've kept it the same. The Python client knows that this is a remote session, and so it will use the remote write-back mechanism that we have built. That went fast, so it only took 10 seconds. You can actually see here that my internet isn't great. That's because now we are actually talking within the cloud provider's network, so network communication is pretty fast there. And so now we can actually make sure that we have written back the result actually to the database. For those of you, again, who have used the Python client before, they might recognize the run cipher method here. This one used to actually run the cipher code on the database where GDS was installed. But now that GDS sessions do not support cipher right now. You cannot query the GDS session itself via cipher. This call will instead go to the database and communicate with the database via cipher. So here we just match all the person nodes and make sure that they have an embedding and the PageRank property. And yeah, they have that. Then we're basically done. Our workflow has completed, and then it's time to actually delete the session. We can do that. And that's it. Now we'll internally clean up all the cloud resources and stop charging any money. And we are ready to create your next session. And just to make sure that the session has gone, we'll run the list sessions again. And now we only see our backup session and the old one has disappeared. Yeah, that's all for the demo. And with that, back to Florentin.
Okay, so now you've seen how everything runs in Aura, but maybe some of you also have the database still self-managed. Also got a solution there. So you can have your database self-managed and use this very similar workflow as Max just showed. There's also a tutorial documented, which I can link later. And the only thing that stays in Aura is the GDS session, makes it easier about version management, for instance. You don't need to care about that one. And also like getting new instances, managing these things. That's just up for us. You shouldn't care about infrastructure there. So let's give you a quick summary of the current features that we're offering. So right now everything is exposed to the Python client. There are docs for the server, on server manual, and as well as our Python client. We support most of the GDS endpoints that are existing. More details on that are in the documentation. For instance, what we don't support is a graph export to database or CSV at the moment. And we also have the session management feature. So there's also a sizing helper, which Max didn't show in the demo, where you can, based on the algorithm groups that you know you want to run and to node relationship count, you can estimate how large your session should be. as Max showed, there's a TTL because we received a lot of feedback about automatic cleanup is a good feature, and people are forgetting to close their instances, and that's just costing them money that they can save. And also we are fixing the version during session creation. That's also one of the reasons why we are limiting the session lifetime to 30 days, to make sure you're not running very outdated sessions. But that's also not the idea around Project Strawberry there. It's intended for other short-lived workloads. And apart from the Python client, there is also already a UI in our console, so especially for admins or so, they can list all sessions in their project and also delete them if they see, okay, that's a long TTL and people maybe already left the company or for some reason, or just the weekend. And with that set of current features, what's the project state in general? We are in an early access program at the moment. It's open for our virtual dedicated cloud customers, so that's the highest tier inside Aura. If you're interested, you can scan the QR code here on the slide and book a meeting with our program manager. Happy to hear feedback there and try it out. And for future ideas, so it's far from every feature we'd like to have, but of course, as engineers, I think we always got new ideas on what we can implement. But what's on the top of our mind is, for instance, a Cypher surface, because people of other languages accept Python. And so with a Cypher surface, you could connect with every other driver that Neo4j itself offers. So broadening the accessibility here. But also something that people often requested in the past is better GNN support. So we only have GraphStage at the moment, GDS, and with Project Strawberry, it makes it simpler for us developers to support also graph neural networks that are, for instance, written in another language. And that's the end of our session, actually. And we're happy to answer questions to you now. And yeah, scan the QR code and hope you join our EAP.
I don't think there are any open questions. As we said, currently sessions aren't available for the general public, but yeah, if you're interested, then make sure to reach out to RG through this link and get in touch with us. We are very interested in feedback. And yeah, if there are no other questions, then thank you for listening.
Thank you.
Bye.